Welcome. This video is going to go over solutions to the mini quiz 6.1 ABCD. So the experiment above is described as excess magnesium added to a beaker of aqueous hydrochloric acid, and line A represents the magnesium, B the HCl, and C the volume of H2 gas being produced. So it says state and explain two reasons why this reaction is relatively slow at room temperature, and there's really three valid reasons you could have come up with. You get a mark for each reason and a mark for the appropriate explanations. So one reason a lot of groups mentioned was the low temperature. Room temperature is fairly low temperature for a reaction. Low temperature means there's going to be fewer collisions. And fewer collisions, of course, is going to decrease your reaction rate. Another common one that some groups hinted at but didn't really explain very adequately is that this reaction probably has a high activation energy, or at least an activation energy quite a bit in excess of 25 degrees. So not many molecules are going to reach that. So a few molecules have this amount of energy. And then the other one I'm surprised that none of the groups mentioned, but you maybe just have a low concentration of HCl. Maybe you use, 0.001 molar HCl, so there aren't many molecules available, which will slow down your reaction rate. Question number 2, state 4 changes and indicate if it's an increase or decrease that would indicate the reaction rate. So you didn't have to explain why they're increasing or decreasing, but you picked up a half mark if you knew what the change would actually be. So the 4 different changes you could look for is, most of you realize volume, and in this case, volume should be increasing if you're collecting the gas. Mass would be another one, and mass should decrease if you let the gas escape. And then the other two that aren't as obvious, pH actually increases as H plus gets converted to water, so you move closer to a pH of 7 or neutral. And then the final one would be conductivity, and you have 4 ions on the reactant side and only 3 on the product, so your conductivity would decrease. One change that really wasn't appropriate for number 2 would be color. There is no change in color. You start with the clear liquid, you end with the clear liquid. I don't think there was anything else that groups mentioned. So those 4 would be the ones that would be most appropriate to this experiment. Number 3 says, state and explain 2 ways to increase reaction rate other than increasing temperature. Most common one mentioned by groups was add a catalyst. And then the explanation for the second mark there is it lowers activation energy. Another one is you could increase the concentration of HCl. Now, a lot of you suggested that we should powder the magnesium, but the magnesium's already in excess. So the limiting reactant is the one that we need to change, and that would be to increase the concentration. So there's more HCl available, since that's the limiter. And those are really the only 2 options you have other than temperature. And then number 4 says a small increase in temperature gives a large increase in rate. State 2 reasons for this. The 2 reasons are simply that you have more collisions, and collisions have more energy. Which one's more important? The greater energy. And the reason why is a collision cannot be successful if you don't have EA, activation energy. A collision can't be successful. So it really doesn't matter how many unsuccessful collisions you have. So again, increasing collisions really doesn't help you unless you increase the number with the minimum activation energy. And going back to number 1, just for a moment, few groups mentioned a reason it was relatively low was the size of the magnesium. Again, magnesium is in excess, so that's not going to affect it. Nobody mentioned this, but I just want to point out another common mistake is to think the volume of HCl, maybe they used a small volume, and volume of HCl would not affect the rate. It would affect how much product, but not how quickly it was made. It would be concentration affecting it.